Now, we know that we need to drink water so that we can stay hydrated. Well, that's very, very true. We want to make sure that our cells always have enough water that they can operate correctly. Because remember, our cells are little more than protein factories. And those protein factories need very specific water concentrations so that we can rely on the chemical reactions to occur in the predictable way that we need them to. So water is going to be very, very important to us. Now, whenever you drink water, what you're doing is you're basically adding some water to your blood plasma. So you're basically thinning out your blood a little bit. You are turning your blood plasma into a hypotonic solution where you have a higher concentration of water inside the blood plasma than you do in the interstitial fluid and in the intracellular fluid. So we're getting a higher concentration of water in the blood plasma than you have in your other interstitial fluids and in your intracellular fluids, which means if you have a lower water concentration over here than you do in the blood plasma, that water then will move from the blood capillaries into the cells. Now, there is such a thing as taking your hydration too far. There was a little bit of a fad several years ago of fraternities and sororities and things like that having their pledges drink gallons of water because they couldn't make them drink a bunch of alcohol. And they thought it was kind of a funny thing, like, oh, well, they're just drinking water. Water is healthy. Well, if you drink too much water, you're making too large of a hypotonic solution. So you're making it have too high of a concentration of water. And we actually end up pushing too much water into our outlying tissues, at which point some of these cells can break and our cells stop functioning the way that they're supposed to. And several people got very, very sick, and even a few people died because of that. So it's something that is really unlikely to happen if you're just kind of sitting there drinking a glass of water every now and then. However, that is at least something to be aware of should someone try and dare you to drink multiple gallons at a time. Now, the opposite of this is also true, though. We know that if we drink water, that we're making our blood hypotonic, and that helps water move by osmosis into our intracellular fluid and into our interstitial fluid. However, the opposite of this is also true. I mentioned a little while ago that our skeletal muscle cells, for instance, have lots and lots of water in them. Well, should our blood get somewhat hypertonic, as tends to happen if you're sweating a whole bunch and you're not drinking any water, well, that means your blood is going to get hypertonic. That means we've lost too much water, which means we have to get water from somewhere to make sure that the blood is going to continue flowing. So where is it going to get that water? Well, it's going to get that water from places where it is in higher concentration now, which is going to be in your intercellular fluid and from your cells and from the spaces between your tissues. That water then gets pulled into the capillaries until we have made everything isotonic again. However, if you don't have as much water hanging out in your muscles and things like that, that's going to be more difficult to do. So you can start to run into some problems with continually hypertonic blood and now some cells that have wonky concentrations of things. So it is very important to maintain that. Now, fluid intake is going to be very important. This is because we have a few things with our fluids that are completely obligatory. So things that we have to do pretty much no matter what, just to make sure that everything works the way it's supposed to. Now, one of the things that people often don't think about is that we are actually going to produce a fair bit of fluid just innately. One of the things that often happens is that we're actually going to expire some water in our air. This is because oxygen acts as the final electron acceptor in the electron transport chain. And when it grabs those electrons, it just simply gets turned into water. So we're actually going to produce something like 200 milliliters of water this way every day, just from our cells undergoing their typical metabolism. So that means we get a couple hundred mils every day just from that. However, our mouths are open and we breathe out, which means we're going to inherently breathe out some of that water. Some like 300 mils is not very much, so we don't really notice that water necessarily. However, it is still something that we have to do. We're also always going to sweat just a little bit. We're going to get warm. We're going to generate some heat. We will end up sweating just a little bit over the course of the day. 100 milliliters, once again, is not that much. However, it is something that will typically happen. The same thing goes with losing some water through our skin. Over the course of the day, we are exposed to the outside. Outside environment is typically drier than our cells themselves. So we will actually have some water just kind of transpire from our skin. Once again, fairly small amount. Now, Feces and urine are also going to be big parts of this. We need some amount of water in our feces to make it possible for us to pass that feces this way, that it is soft enough that we can actually pass it through our bowels and pass it through our rectum. Without some water, that's not going to happen. This is why one of the things that most drugs that treat constipation are doing is actually trying to force additional water into the urine so that we can make it soft enough that we can pass it. Now, we're also going to lose around 500 milliliters of water in our urine every day. This is because we are generating a bunch of metabolic wastes. Okay, so we're generating a bunch of metabolic waste and we have to get rid of those. If we cannot get rid of our metabolic waste, we will run into massive problems. Kidneys will start to fail, or that may be a sign even that our kidneys are failing. It also, our liver will run into problems. We will get tired. We run into lots and lots and lots of issues if we have these buildup of metabolic waste. This is why it's so important for people that are on dialysis to make sure that they are continuing to do their dialysis treatment to make sure that we can get those metabolic wastes out of there, because they are poisonous to our cells. And we're going to have to then get rid of about a half a liter of fluid this way every day. Now, we also are going to tend to get rid of around another liter of urine a day that is facultative. Basically, that is something that will happen as long as we are drinking enough water. Now, most of the water that we're going to take in, we know we're going to take in the form of drinking it, either through coffee or tea or however you get your fluids. That tends to be the bulk of our liquid. However, your food is also going to contain quite a bit of liquid. Now, the more plants, the more fruits and fruits, vegetables, and stuff like that you're eating, the more water you're going to get than if you're, say, eating grilled chicken. However, there will still be water in basically all of your food. It's not nearly as much water as you're actually going to be drinking as just drinking. Now, I mentioned a second ago coffee and tea. These are all still sources of water. These do hydrate you. However, they do less of a good job hydrating you than does something just like water. That's because water is going to be more hypotonic. It's going to make your blood more hypotonic, which means it's going to do a better job of pushing those fluids into your tissues. Now, all of this is, of course, balanced out. If you drink more water, so say instead of 1.6 liters, you drink 3.6 liters. Well, if you're drinking 3.6 liters of water, that likely means that water will come out via our urine. You may see a little bit more water come out through your feces, but most of that extra water we are going to get rid of facultatively through our urine.